So probably you have seen that in many textbooks is just indicated that the limit as x tends to 0 of the expression sine of x over x, well, is 1. And we'll take it just the way it is without any question. But it doesn't seem to be quite obvious that we could factor an x from sine of x, right? Just to indicate, like by means of, for example, some radical manipulation or some fancy factorization. Why don't we take a geometrical approach? Right? So I'm going to compute not specifically the limit as x tends to 0, but one of the decided limits. In other words, I'm going to let t be a number comprehended between 0 and pi over 2. Why? Because I want to interpret this as an angle, right? As an angle between 0 and 90 degrees, excluding those two possibilities. Okay, with this in mind, I'm going to provide a picture. So I have here x, y, and then here the angle t. And now a few designated points. So I have the origin, I have B, this point, I have A, and I'm going to make a following. Across B, right, I'm going to draw a tangent line. And I'm going to extend this radius, right, until it touches this part. So I call this C. Okay, so now look, we have the following. What I'm saying is that this is the unit triangle. So this circle satisfies the equation x squared plus y squared equal to 1. But now, in virtue of this, and of course this is the line x equal to 1, right? So that is the geometry associated with all of this. But what do we have? Well, look, note that we have three objects. The first one will be the triangle. Given by the origin, the point A, the point B. The second one, the sector, given by the origin, the point A, and the point B. The sector being this portion of the circle. And finally, 3, the triangle, given by the origin, the point C, and B. Right? This one that I'm denoting here. Okay, but what do we know? We know, just from the geometry, right, that the area of the triangle given by the origin A and B is less than or equal than the area of the sector given by the origin A and B, which in turn is less than or equal than the area of of the triangle here given by the origin C and B. Right? We can take this from the picture, right? From this geometrical consideration. But then let's express each of this. First, the area of the triangle origin with A and B is, well, nothing else but 1 times the sine of t divided by 2. Why is this? Well, look, the base of the triangle, right, is nothing else but a radius, right? And the height of the triangle, right, being this on the unit circle, right, would be given by the opposite. The opposite divided by the hypotenuse, right? The hypotenuse of this small triangle inside, right? Okay. What about the next? Well, next thing, the area of the sector. Of the sector given by the origin A and B. Well, that one is what? Well, is t over 2 times 1 squared. Why? Because this is just a proportion of the circle itself, right? This sector is just a proportion of that circle. And to what proportion? Well, to that of t over 2, right? And you can verify this with a small table if you like. And well, next thing, the area of the triangle given by the origin C and B. Well, but this one, again, has base 1, as indicated here. But its height, well, being this a 90-degree angle, right? Tangents make a 90-degree angle with every radii, right? At the point of intersection with at the the tangent point to a circle will be given by 1 times tangent of t, all divided by 2. And why? Well, look, this is a right triangle, and you can simply write the tangent of t as opposite, right, over adjacent, but adjacent is 1, right, in this case. Okay, so look, we have that the sine of t over 2 is less than or equal than t over 2, which in turn is less than or equal than the tangent of t divided by 2. Well, but with this, look, we can write the following. So, sine of t is less than or equal than t, and is less than or equal than the tangent of t, which we know, well, is equal to the sine of t divided by the cosine of t, right? It's just a different way of writing tangent. Well, but let's see. What else? Well, recall that t is greater than 0, so 1 over t is greater than 0. So I can simply make the following multiplication, and I can say, well, sine of t divided by t is less than or equal than t over t, which of course, it's 1. But then look, this might not be sufficient. Why don't we try the following, right? As this indicates that, in fact, this expression that we have here, right, is less than 1 or equal. But if we don't know what would happen below this, so we have to bound this expression below, right? We have bounded it above, but we need to bound it below now. What can we do? Well, that's why we make this intervention, right? Because now I'm going to re-express this in the following terms. On the interval, t from 0 to pi over 2, cosine of t is also positive. So, what do we have? We can multiply this whole inequality, right, by cosine of t, and we will obtain the following. Cosine of t times sine of t is less than or equal than t times cosine of t, which in turn is less than or equal than sine of t. One more time, we're going to multiply by the reciprocal of 1 over t. I'm sorry, by the reciprocal of t, which is 1 over t. So we'll get the following equivalent equation, inequality. We have cosine of t times sine of t divided by t is less than or equal than the cosine of t, which is less than or equal than sine of t divided by t. So look, now we have the following. You see? I have that sine of t over t is bounded between this quantity and this one. So we have that the cosine of t is less than or equal than the sine of t over t, which is less than or equal than 1. Of course, right? For t greater or equal than 0, or greater than 0, right? Well, let's take limits. Taking limits on the right, we get this. The limit as t tends to 0 on the right of the cosine of t is less than or equal than the limit as t tends to 0 on the right of sine of t over t, which is less than or equal than the limit as t tends to 0 on the right of 1. Of course, this is a continuous function, and a continuous function you just ask for evaluation. So this is that the cosine of 0 is less than or equal than the limit as t tends to 0 on the right of sine of t over t, which now, this being a constant, hence continuous, is just less than or equal than 1. But the cosine of 0 is 1. So we have that 1 is less than or equal than the limit as t tends to 0 on the right of sine of t over t, which in turn is less than or equal than 1. But you have that a number, this limit, is bounded between 1 and 1, so it better be 1. Now, a similar construction can be said about taking the limits from the left, but I leave that as an exercise. So I hope that you like it. Take care and enjoy the rest of your day.